All right, hi everybody. We're working through the trigonometry review for calculus here. Just working through a related rate problem. It says a lighthouse is situated 200 meters from a straight shoreline, and the light rotates clockwise at 2 revolutions per minute. At what speed is the beam of light moving along the shore when the angle between the beam and the nearest point on the shore is pi over 6? Okay, so what we're going to do here is we've got this lighthouse here. Okay, we're going to just draw this out to start off with. This is 200 meters away. The searchlight is rotating clockwise, so it's going to be shining a light out here along the shore. Now you got to think of this as more like an area view, like we're looking down on it from some sort of airplane. So here's the shore, there's the lighthouse. Here's our theta here. Now we are given some information about that. We know that that thing is rotating at 2 revolutions per minute. So d theta by dt here at 2 revolutions per minute is going at 4 pi radians per minute. Okay? Now, I'm interested in how fast this point along the shore is moving. Now, this thing is moving clockwise. It's moving this way. So that this thing is moving this direction here. This is x. The trig function here that I probably want to use is because I'm not given any information about the hypotenuse, it would be tangent. So the tangent, whoa, I kind of wrote that a little weird. The tangent of theta is going to equal x over 200. The derivative of tangent will be secant squared theta, but remember, because I'm looking for the derivative with respect to time, I got to do this implicitly. So this will end up being 1 over 200 dx by dt, and that's that dx by dt that I'm looking for this time. So now I'm going to multiply across by the 200. So 200 secant squared of theta, d theta by dt is going to equal dx by dt. Okay, so now we just got to plug in what we know. Well, we know this is going to be 200. We also know that at the point that we're interested in, the question says, at what speed is the beam of light moving along the shore when the angle between the beam and the nearest point on the shore, so the angle between the beam, the hypotenuse, and the nearest point on the shore is pi over 6. So now we come and we plug in pi over 6 in for secant, and then d theta by dt we've discovered was 4 pi. This will be dx by dt. And now this is really just a matter of evaluating. What we're going to get here is secant squared of pi over 6. Okay, well, first of all, secant is 1 over the cosine. Okay, so the cosine of pi over 6 being 30 degrees, cosine of pi over 6 would be root 3 over 2. So secant would be 2 over root 3. Squared will be 4 over 3. So this is going to end up being 200 times 4 times 4. This is really going to be 200 times 16, okay, or 3200 pi all over 3 equals dx by dt. Okay, I could probably get that a little finer. We could probably do that in terms of well, in fact, I probably should, because we're asking for how fast is it's going. So what I'll do is I'll multiply that by pi, divide that by 3, and we're getting that light is shooting along there at 3,351.03 meters per minute. And that's the speed that's shooting along the shore.